In question number 4, we're going to put all the pieces together so that we can really compare once and for all the different types of interest rates you've seen, so that you can really start to tell why it makes such a difference to compound interest and why in the long run it's worth understanding it in the big picture of adulthood, and especially when it comes to money and investments, because that's where you'll see it the most. In question number 4, this guy is inheriting $20,000, so a nice big chunk of money, and is given 3 options for his investment accounts. Each of the investment options gives you the same exact initial value, but the growth rate is different. Option number 1 wants it to grow in what we call a simple interest way of $1,000 per year. That would be an arithmetic situation where you just add 1,000, add 1,000, add 1,000, add 1,000 once a year, every year. Option number 2 is going to give you 4% a year. So instead of 1,000, it's going to be 4% of whatever's in the account, and that's going to compound annually, which just basically means once a year. Option number 3 is going to give you the same 4%, but you'll get it over the course of 4 years. So remember how compounded means divided? Dividing the year quarterly means that you're going to get smaller chunks of your 4% 4 times a year, instead of option 2, which is where you just get it in one lump at the end of every year. So this is really the difference that we want to explore. Annually, which is once a year, versus quarterly, which is where you divide it into 4 smaller chunks. Let's look at each option's equation. As we already said, option number 1 is arithmetic. So arithmetic equations always start with their initial value, which would be 20,000, plus, because we're adding interest, 1,000 per year. Remember, arithmetic is the one that uses a regular size variable, not a power. Option 2 is definitely going to be geometric because it's got a percentage, which means it's going to have a multiplier, which means it's going to be geometric in structure. So y equals, the initial value is still 20,000, times, I'll do a little bit of mental math here, I have 100% of my money in the account plus 4% more. That's 104% of my money. And 104% as a decimal would be 1.04 to the power of x. It is worth noting here so far, x represents how many years the money has been in the bank. So x is years, and here I'll label it x is years. The labeling isn't mandatory, I just like to do that to keep track, especially with word problems like this. Option number 3 I have to think about a little bit because they're still going to give me 4% a year, but it's going to be divided into 4 smaller quarterly payments, so I need to think about that first. 4% a year, that's the annual rate, divided into 4 smaller payments is really 1% each payment, and it's that 1% that I want to turn into my multiplier. So 100% plus 1% would be 101%. That's a multiplier of 1.01. So option 3 is going to have a very similar looking equation to option 2, but its multiplier will be 1.01 to the power of x. And it's also worth noting here, x in this case is the number of quarters that the money has been in the bank. Because notice, if we're compounding quarterly, that means we're counting our time in quarterly increments, not yearly increments. So quarters will be the significance of that x. Now, let's see if we can see how this growth is going to take account for us. If he keeps his money in the account for only 1 year, how much will each option be worth? Let's test each one. The first option, 20,000 plus 1,000 times 1 year would be 1, plugged in, would be $21,000. Pretty good. Definitely more than we invested initially, so you can tell we've made money. That's a good thing. Option 2, 20,000 times 1.04 to the power of 1 year, x is years, so I can just plug 1 straight in. 20,800. Not as good, apparently. Still not bad. I mean, I've still made money compared to what I started with, but option 1 seems to be a better short-term choice right now. Let's try option 2, 20,000 times 1.01 to the power of, now I have to be careful, this one's measuring in quarters, So 1 year has 4 quarters in it. I'll use 4 as the variable I'm plugging in, and that's 20,812 and 8 cents. So if I think about this logically for a second, I can certainly see that if I was to only keep the money in the bank for 1 year, option number 1 looks like the best choice because that one yields the most of all 3. Now, if you've just said to yourself, well, Herbert, no, you said compounding is best. I thought you meant that like option 2 or option 3 was always going to be better. It's worth paying attention to here that in the short term, compounding doesn't actually do a whole lot for you. And in the short term, a very simple arithmetic growth actually does cause a very significant increase. So let's think about this as we transition to letter C, short term versus long term, and see if there's a more visible difference after 5 years. So I'll go back and I'll do the same thing. I'll plug back into my equation 5 years worth of time. So first equation, 20,000 plus 1,000 times 5, that's 2,500. Sorry, 25,000. Option 2, 20,000 times 1.04 to the power of 5 years, 24,333. Still looks like simple interest might be better. Option 3 is 1.01 to the power of, now I have to be careful, 5 years measured quarterly is actually 20 quarters. And then we have 24,403 and 80 cents. And we look at our options again and we say to ourselves, option number 1 still appears to be best. Herbert, I think you were wrong. Herbert, I think you're mistaken. The simple interest doesn't seem to be making that big a difference. And I can certainly see why you would say that. I mean, it seems as though the compounding options really aren't as advantageous as this simple one. But the thing that you should remember about this in general, is more of a life lesson, not just a math lesson, is that banks don't really benefit, and nor do you, from short-term investing. Although 5 years probably sounds like a long time, in the investment world, 5 years is actually a very, very, very short-term investment. And most people who do investments do so for much longer spans of time. We're talking like 20 years, 40 years, 50 years, to the point where you would be of retirement age finally looking at your money. So just in case you're kind of curious about how that growth looks over time, it may be worth noting, and I'll just do this because a graphing calculator has this capability, that if you look at the pattern, 20,000 times, plus 1,000x, side by side with the other 2 options, and I'm going to try to do this just so you can see it, to the power of, I'll have to convert that to quarterly so it makes sense. If you start to look at a table where you can compare them side by side, you can see that in the short term, this first option, which remember is the arithmetic option, still looks like it's the advantageous way to go. It's clearly earning you more money, although the gap is starting to get a little smaller. Remember how at first it looked like it was significantly more money to do it arithmetically? By 10 years, this option 3 isn't that far behind. But notice what happens as I go to, say, 16 years. Now all of a sudden, the compounding options look better. And if I keep going, let's say a pretty common investment option, 25 years, now it's significant that compounding it quarterly is earning me more money than the other 2 options. Significantly more money than the simple interest, the arithmetic one. If we go for a really long span of time, like 50 years, then the difference becomes much more pronounced. Notice $80,000 for a 60-year investment versus $217,000. Hugely different.